Okay, welcome to 6.1 lesson over law of sines. We are going to be learning how to solve non-right triangles using the law of sines. Non-right triangles are known as oblique triangles. So over here in your toolbox, you'll see some terms. Oblique triangles are those that do not have a 90-degree angle for any of the angles. So the examples we're going to be working today involve non-right triangles. Therefore, we cannot use formulas such as sine equals opposite over hypotenuse and cosine equals adjacent over hypotenuse. And we cannot use Pythagorean theorem because all those types of formulas that we were using last semester were specifically used to solve right triangles. So what do you do when you have a non-right triangle? Well, you are going to end up using what we call the law of sines and the law of cosines, which you will learn in the next unit, in the next section, to be able to solve these given triangles. So down below, you see a box containing the formulas for law of sines. But when we proceed a little bit further into an actual example, I'll show you how to use those proportion formulas down below. In our essential question, you are going to notice as well that there are a combination of capital letters here, and these are used to help classify your triangles that are given to you, okay? Now, the capital S stands for the word side, and the capital A stands for the word angle. So what you're going to do is when you are given a problem, you are going to see what's given, and by looking at what's given, be able to determine if it's an SSA problem, an AAS, or an ASA. Now, you might realize that these two right here that I'm underlining, AAS and ASA, they look very, very familiar. So in order to be able to differentiate between these two, here's an example of an oblique triangle given some measurements, okay? So let us say that the angle that I've given you here is 120 degrees. If I can draw an actual circle. And then this angle right here is given to you as 20 degrees. And for some reason, I can't draw those degree symbols. And then right over here, the length of this side is a 12. Okay? So in this situation, you have been given two angles and a side. So you have an angle over here, you have another angle right over here, and you have a side length given here. Well, that's an angle side. If you want to see what an angle side angle would look like, you would have been given this angle, again, let's call it 20 degrees. You would be given this angle, let's call that also 120 degrees. But instead of the side being given over here on the far right, we're going to put the length of the side to be right here as 12. Notice this time, you are still given an angle and an angle, but this time the side is trapped in between both angles, okay? So this here would be an angle side classification, whereas this one would be an angle side angle because the side length is trapped in between both the angle and the side. The side length is trapped between both angles, okay? So that's the difference between these two classifications. Regardless, those two and SSA, if you have a triangle that classifies as either one of those three, you are going to use the law of sines to solve the triangle. So let's move on to the first example. So here's our first example. Example 1 wants us to solve the triangle and find all the missing values. So the first thing that I want you guys to do when you are solving a triangle is I need you to set up all the given information, okay? So let's do that. Our angles will always be depicted by capital letters, and our vertices here are capitals A, B, and C. So what I want you guys to do is come over here, and on your note-taking guide, you can go to the far right of your note-taking guide in that blank spot, but your capital A is going to be 56 degrees. Your capital B, we don't have any values for it, so we'll leave it blank. And capital C is 41 degrees. The length of sides will always be depicted by lowercase letters. So in this case, it's A, B, and C. And they always correspond to the angle in the sense that you will notice that the length of sides are always directly across from the angles. The length of the sides are always right across from the angles, okay? So A was not given, B was not given, and 12 is across from angle C, so that is lowercase c. So at this point in time, we are looking for lowercase a, lowercase b, and uppercase b, an angle. So if you have a highlighter, go ahead and highlight those values that you are looking for, okay? Now, what I want you to notice too is that when you are given information, look to see if you have a matching corresponding pair where they're both being given right off the bat. So in this example, I want you to notice that right off the bat, angle C and its lowercase c were already given, okay? So I want you to pay close attention to the fact that I put asterisks next to them, because we're going to come back as to why I mark those always when I have that matching pair, okay? I'm not marking B's and A's because they're missing information, okay? But the C's were completed, so I'm marking them, and you'll see why. So the first thing I want to do always is if I'm given two angles, okay? So over here I'm going to tell you in your notes, if given two angles, find third, because you know that the sum of all angles in a triangle is going to be 180 degrees. So frankly, it's pretty straightforward as to what we need to do, okay? So to find angle B in this scenario, we know that 180 degrees minus the degrees we already know, 56 degrees and 41 degrees, will give us the remaining degrees of angle B. Okay? So go ahead and work that out and see what answer you get. Okay, so at this point, you should have got 83 degrees. So take that answer that you found and come upstairs here and fill in your 83 degrees. Okay? Now we are going to proceed to find lowercase a and b, which are the side lengths. This is where we will use our law of sines. So I'm going to first look for length of a, okay? The length of lowercase a. So if I look back, I'm going to turn back one page here. If I look back at my formulas, lowercase a is located right here and right here. And so I can use this proportion or this proportion, okay? It doesn't matter which one you use because either one will yield the same answer. But I'm going to tell you right now that I personally like to use the one in the numerator, okay? Anytime I'm solving for a particular thing, I like to solve using the proportion that has my value in the numerator. So I'm going to use the a over sine a formula rather than the sine a over little a formula. So I'm going to use this formula. Now let me explain to you that it does not matter which one you use. They both will yield the same answer, okay? It's just a matter of preference. So I'm going to go back to our page, and I'm going to use little a over sine A. So I'm going to start out here. Little a, which is what I'm looking for, over sine of capital A, which in this case, capital A is 56 degrees. And then I'm going to equal it to another fraction. This fraction on the right-hand side of the equal sign is the one that I always want you to put the asterisk information in, okay? Your right-hand side fraction is always going to be the information you already know. So in our information above, that was the C information. So upstairs are the lowercase numbers, so I'm going to put the 12 for my C here. And down below, I'm going to put the sine of capital C, which in this case is 41 degrees in the in the denominator. Okay? So put your asterisk information on the right-hand side. So now I'm able to solve this equation. Okay? So what I'm going to do, I have a proportion. I cross multiply and divide to be able to solve and isolate my A. So what I do is I cross multiply first, those two values, and then I'm going to divide by the last value of sine 41. So A will just be 12 times the sine of 56 degrees. Don't forget to put your degree symbols always. And I'm going to divide by sine of 41 degrees. Divide always by the one that is matched up with your variable. And so now all I'm going to do is type this into your calculator. If you're using a graphing calculator, the TI-84s, all you need to do to get the stacked fraction is to press the second button and then press the Y equals button. And then right off the bat, you're going to see on the calculator, you'll get a stacked fraction bar, so that you can enter the information upstairs and downstairs, okay? So second Y equals. But anyhow, all you're going to do is type this information into the calculator, and then once you get that answer, your A value for this problem is going to be 15.16. We're going to round to the nearest hundredth place, 2 decimal places. So upstairs, I am writing 15.16. Okay, so there's that part. So now that you know how to solve for A, I want you to practice doing the same thing now, but now I'm looking for B. So I'm going to start off with B in the numerator this time, over something equals, put the other fraction, and don't forget again, this fraction is always the asterisk values, okay? So go ahead and pause this video here for a second, and then you will see how to work this problem out. Okay, so here is the answer. So notice how you set up the problem identically. You still use the asterisk proportion of the given information that you already know, cross multiply and divide. And in this case, when you solve for B, you'll end up with 18.15. And then notice right off the bat, you are done. You found the 3 missing features because there's a total of 6. I will always give you 3, and you look for the other 3, okay? Now, one thing that I completely forgot to do that I need to make sure that you guys are always doing is when you start out the problem, make it a habit to first figure out what the classification of your problem is, because you need to know how it's classified to be able to determine, am I going to use law of sines or law of cosines? Now, of course, we are just in the section called law of sines, so all your problems are going to be that, but eventually you will have a mixture and you'll have to be able to determine which one is which. So remember, classification has to do with what is given. So in our problem, I'm going to use, let's use light blue here. In our problem, you were given an angle right here, light blue. You were given an angle, here was another one, and you were given a side, okay? So you have an AAS. So that means you either had an AAS classification or you have an ASA classification. So I need to look at this picture and be able to determine, well, is my side length, remember this is what I told you guys, is my side length trapped in between two angles? Well, my side length was right over here. Here was my 12. And my angles were right over here. Does that side length look trapped between these two angles? No. So that means my classification is angle, angle, side. Okay? Because this 12 is not trapped between these two angles. Okay, if it was angle, angle, side, the 12 would have been right there. Okay, but it is not. So hopefully that makes sense. Okay, so don't forget to classify. So if it's an AAS, that's what gives us the green light to be able to use law of sines. Okay? All right, example number 2 on your note-taking guide, we are skipping. You guys can use that to practice on your own. Let's go to example number 3. So in this case, we do not have a picture of a triangle, but that's okay. You still proceed with the first step. I've told you guys, set up your vertices, capital letters A, B, and C, and set up your lowercase letters A, B, and C, and substitute what you do know. They gave us capital B is 20.5 degrees, 20.5 degrees. Notice anytime I write for my capital letters, I'm always putting a degree symbol. So please don't forget that, okay? Capital C is 131 degrees. There's my degree symbol. And A is 12. So take your highlighter, mark what you're looking for. Capital A, capital B, and capital C. So let's start off with classifying. Let's see if we have permission to use the law of sines, okay? So what was given to us? Well, an angle, another angle, and a side. So again, we're looking to decide, is it angle, angle, side, or is it angle, side, angle? Okay, let's see which one is it. Both of them belong to the law of sines, so in essence, it doesn't really matter which one, but I want you practicing knowing which one's which, okay? So we're going to draw a random triangle to kind of give us a picture. So I know that one of my angles is 131, so I know that that angle is going to be pretty wide. So I'm going to do a pretty wide angle here, and I'm going to say that this angle here is 131 degrees, and it's angle C, and then I'm just going to connect these right here. And then I know that angle B is 20.5, so let's call this angle 20.5. 20.5 degrees, and that is angle B. Therefore, this has to be angle A. Okay, and then they tell us that the length of A is 12, so that's going to be right here. So look at the position of our given information, okay? Notice that the 12 is trapped in between those two angles. So that pretty much helps us see. So this is your angle, this is a side, and here's another angle. The 12 is definitely trapped in between that angle and that angle, okay? So it is safe to say that our problem is going to be an ASA type problem, okay? So ASA is our classification. So just like the previous problem, we have the green light to proceed to use law of sines, but since we have two angles, let's just get the easy stuff out of the way And let us solve for that missing angle measurement. So capital A, I'm going to come over here to the right. Capital A is going to be 180 degrees minus the 20.5 degrees minus 131 degrees equals, and what do we get there when we solve that? So go ahead and type that out, and what do you get? All right, you should have got a 28.5 degree angle. So let's come over here to the yellow spot, type 28.5 degrees, and now I have 3 angles and 3 sides. So notice what happens now, right? Now that I have those 3 angles and 3 sides, I have a pair of characteristics that are completed, the capital A and the little a, and that's great. That's what I always want to look out for, because that helps me solve using law of sines. So I am going to go look for little b first. I can do C or B, doesn't matter which one you do first, but I'm going to look for little b first. I'm just going to stick to the alphabet. So since I'm looking for B, I'm going to put B in my numerator, little b, over sine of capital B, because if you have a B in the top, you have to have a capital B in the bottom. So in this case, my capital B is 20.5. Notice I put my little degree symbol, equals, and the fraction on the right-hand side is always going to be my starred asterisk pair. So if I have a lowercase here, I have to have a lowercase here. So my lowercase here is going to be a 12, and sine of its corresponding angle, which is 28.5 degrees. So again, nothing has changed. Proportions lead us to do cross multiplication. So I'm going to set B equals to the multiplication of those 2 numbers, and then divide by the number that would be paired with the B value, okay? They're right here across from one another. And I'm going to type that out into the calculator, so take a moment practicing. Go to your graphing calculator and type that out. And you should end up with the answer of 8.81. So I'm going to go back up here and put it in my chart. 8.81. So you're almost done. So I want you to pause the video now here, and I want you to go find C. Okay, you're going to go find C now. So go set up your proportion and solve for the length of C. Pause the video now.
Sorry, I don't know how that's done.
Okay, so here is the setup to find the length of of side C. 12 sine 131 divided by sine of 28.5. Once you put that into your calculator, you should have ended up with the result of 18.98. Okay, so notice that the approach for a classification triangle of angle side or angle side angle, the approach to be able to solve these type of triangles, these oblique triangles, is the same. You first find the missing angle because you've already been given 2, and then you set up proportions using law of sines to solve for the 2 lowercase letters, which are the length of the sides. Okay, so everything that you are seeing right here as far as the proportions, these are the law of sines being used. Okay, that is the law of sines. Okay, all right, so let us move on to example number 4. Now you're going to notice on your note-taking guide that there's an example number 5. Don't worry about it. We are going to work on application problems at a later date, but it is still a worthy problem. Don't think that I am getting rid of it because it's not a good problem. It's just we are postponing it, okay? So let's move on to example number 4. Example number 4 is providing us with a drawing, so we don't need to do any sketches. Our vertices are still capital letters A, B, and C. So let's go ahead and set it up. Now, please know that your letters are not always going to be A, B, and C. When you do your assignment, you're going to notice that they are going to switch up the letters. They use R, S, T, M, N, O, all those type of variations, okay? So let's give the 30 degrees to the capital A here. The 8 is across from capital A, so we go right here. The 10 is across from angle C. So we are left with this information here to find. Okay. So, again, you will always be given 3 pieces of information, and you are hunting for the answers for the other 3. So starting off this problem, we start with classification, okay? And this one's going to be pretty straightforward in its classification because notice this is an angle, an S, and another S. So this will end up being your SSA type classification. 2 sides and an angle were given. And whenever you have an SSA classification, that tells us that, yes, you are allowed to use law of sines, okay? So, notice that in this problem now, because we are only given one angle, 30 degrees, we cannot just say, oh, I'm going to find the angle by taking 180 minus, and it's not going to help me. I don't have enough information. I have 2 angles that I need to look for this time, and so 180 minus angle is not going to work. So what do we do? Well, you are still going to proceed looking for an angle, but here's the different take that I need you to understand. First note, before we start out, that we do have a matching pair. Not a matching pair, but we do have a pair of features of angle side combination that's been given to us, so that's really great news. So as far as setting up our proportion, we have one side of the equal sign completed. The question is, do I solve for angle B or angle C first? Well, you are going to want to solve for angle C first because it has more information than the B's do, okay? It has a side length, and that is always a good thing, all right? So let's solve for let's solve for C. So solve for angle C. So because it's angle C, capital C, okay, that I'm looking for, please notice it's capital C. Let's go back to our formulas. Capital C, where is it located? So let me erase here a second. Capital C is located right here in this section and in this section, okay? Now, it does not matter which one of these proportions you use, okay? Does not matter. It works well with either one. But my personal favorite is going to be this one because, again, capital C is in the numerator, and so that's why I choose it. But if you want to use the one on the left, please know it works the same way, okay? So I'm going to use this one right here, sine capital C over little c. So I'm going to come back over here, and I'm going to put sine of capital C, because that's what I'm looking for, sine of capital C over little c, which is 10, equals, to the pairs that I do know, sine of capital A, in this case it's 30 degrees, over the lowercase number, which in this case will be our 8. So notice how our fractions are flipped, but what I'm looking for is in the numerator. I always like it here on the far left upper right hand corner. It's just easier for me to always visualize. That's why I always like using the fractions when they are in the top left hand corner. So that's just a personal thing that I like. So we are going to cross multiply. So we cross multiply and divide. So now we have sine of angle C equals 10 times the sine of 30 degrees over 8. Okay? Now look what happened though. When I wrote this out, notice that angle C is not by itself on this side. It has this word right here, this function, sine with it. So I have to get rid of it. So in order to get rid of sine, I need to move it to this side of the equal sign because I can't just come in and erase it if I felt like it, okay? So if you recall from last semester, if I'm solving for an angle, the sine or the cosine or the tangent, when it has to move, so to speak, it will become an inverse, sine inverse of this entire quantity. So when you type it in the calculator, I literally want you to type the sine inverse first, what's in red, and then type 10 sine 30 divided by 8 and hit enter. And once you have typed that out, so I want you to go ahead and practice doing that. Make sure your calculator is in degree mode. I should have told you that since the beginning. Capital C will end up being, let's see, for this particular problem, the answer was 38.68 degrees. So angle C should be 38.68 degrees. So you will come up here and fill in your box. Okay? So type sine inverse, and then it should have an automatic open parentheses. Type this out, 10 sine 30 over 8. Close parentheses, hit enter, and you're going to get 38.68. Now, here's one thing I do want to tell you guys. If you get an error message right here, by the way, if you get an error message when you take the inverse, your problem is done. You are going to tell me no solution, okay? And you're done. If you get an error message, only if, so I'm going to put that word if here. If you get an error message in your calculator, after you hit enter, you are going to tell me that the answer is no solution. In Delta Math, by the way, I'm going to tell you right now, in Delta Math, you are going to see a box where you usually put your answers, but over here on the far right, there are two buttons. One's a minus and one's a plus. I need you to type the minus button, like press it, and when you press it enough times, you are going to see the box disappear, and then two braces are going to appear that look like this, okay? That's what you are going to select. So submit it. That's the symbol for empty set, which means no solution, okay? So if you get no solution, hit the minus sign until you get those symbols, and then go ahead and submit. That's how you enter no solution in Delta Math, okay? Okay. Now, for this particular problem, of course, there is a solution because our answer is positive, so we do not need to do the braces, okay, or write the no solution. And by the way, if you have more than one solution, hit the plus sign, and that will cause the one box to duplicate and have another box so that you can write stuff in it, okay? Okay, so let's go back to our problem. We found angle C. So now that we have angle A and angle C, we can easily find angle B. Angle B is going to be 180 degrees minus the 30 degrees that we already had minus the 3868 that we just found. So angle B is going to equal what? So do the math there. And you are going to see that you get what? It's going to be a rather big number. And so if you got this, you are correct. 111.32 degrees. So notice now, you are down to doing problems just like the angle side and the angle side and the angle side angle. You have enough information to set up your law of sines. You're looking for B. So I'm going to write B over sine of capital B, 111.32 degrees, equals the lowercase, well, our asterisk was upstairs here with the A value, remember? I'm underlining it here just in case you forgot. Our A values were the paired asterisks. So our little a is 8, and sine of big A is 30. So now we have a proportion that's ready to be worked out and solved. So we have that cross multiplication right there. Let me use a different color here. We cross multiply and divide by the other number. So B is going to be 8 times the sine of 111. We are going to cross multiply and divide by the sine of 30 degrees. So when you go ahead and enter all that into the calculator, you are going to get a B value, rounding to 2 decimal places, of 14.91. So let's put that in, 14.91. Okay. Okay, so we have all 3 angles and all 3 sides. But here's the thing that I need you guys to realize about the case we call SSA. This is such a special classification that it is known as the ambiguous case. Ambiguous case, okay? With the SSA classification, and it's only this classification in law of sines, it doesn't even happen in law of cosines, okay? With the ambiguous case, you actually have 3 scenarios that can happen, okay? There are 3 possible scenarios that can happen. With SSA, you can either have a solution where there is none. You would write no solution. You will end up with a solution where there's only one triangle, which is the cases that we've had in both of the examples that we've done in example 1 and example 3. Or the last scenario is that there are 2 triangles that exist, okay? So you either have, they're going to be giving you some features, and your features result in no solution, means no triangle can be drawn with those measurements. Or you can see that, oh yeah, there isn't a triangle that exists with those measurements, but there's only one. Or the last scenario is, yes, those measurements actually can draw 2 separate different triangles. And so you are going to have to make that decision when you have an SSA problem. So anytime you guys see ambiguous cases, notice that you have to ask yourself, is it no solution, 1 triangle, or 2 triangles? So here's what I want you to notice. In our problem right now that we've worked out so far for SSA, we were able to find 1 triangle. So how do I know this? Because this here that I'm circling right now, okay, all that is the information for 1 triangle. But I'm not sure if there is a second triangle. I know that there is that the answer is not no solution. So notice I'm going to cross through no solution because, reminding you again, remember in this step right here, I told you you will only write no solution if you get a negative angle or if you get an error message. So that discounted the fact that it was no solution. So we're good there. So now we move on and we keep solving it, and we realized, oh, well, wait a minute. We got 3 angles, 3 side lengths, so it looks like it's one triangle. So I'm going to put a question mark here. So far, it looks like it's one triangle. So if you have one triangle, what you have to do is test to see if it actually has another triangle, okay? So if one triangle works, you have to do some extra work. So here's what you're going to do. So notice this problem. I'm moving on to the next page. All I'm going to do is redo this problem all over again. So if you find one example to work, which it does, I need you to redo the problem, but change one thing. So here's my problem, and I'm going to redo it again. So what you're going to do is check to see if another triangle exists. Okay? So, start the problem all over again, just like you did earlier. Okay? And put in your given information. So the given information was A was 30, C was 10, and A was 8. And we did not know what this was, and we did not know what this was, and we did not know what this was. Okay? So this is how we started out the problem, did we not? So here's what you do to see if there's a second triangle, if there is another triangle other than the one you just found, okay? What I need you to do is go back to other triangle, find the measurement of the first angle you found, and when you do that, I want you to take that number and subtract it from 180 degrees. Okay? So go back to the other triangle and find the measurement of the first angle you found and subtract it from 180. So I'm going to go back to the previous page. What was the first angle you found? So hopefully you are noticing that the first angle I found was angle C. Okay? That was the first thing you found. Angle C was 38.68. So what I want you to do is subtract 38.68 from 180. So 180 degrees minus 38.68. That's your C value from the previous problem. And the answer you get is going to be the brand new C value for this problem. So when you do that subtraction, the new C value you get is what? You are going to end up with 141.32 degrees. So I want you to take that answer and put it right here. 141.32 degrees. Okay? And then continue to work this problem out just like you did the previous one. You don't even have to look back at the other problem anymore. Okay? The next step is to find the other angle, because once you have two angles, you can always find the third angle. So capital B is now 180 minus 141.32 degrees minus 30 degrees. So go ahead and subtract those. All right, what you should have got was 8.68 degrees, which is a answer that makes sense. So I go here and put 8.68 degrees, okay? Now, here's what I want you to understand, okay, here. If, for some reason, if you get a negative angle, anytime you get a negative angle, that's wrong, okay? If you get a negative angle, comma, then stop, okay? You don't need to go any further. If you know that the work you typed out was all correct and you end up with a negative answer, just stop. That means this second triangle that you're trying to complete is not working out. So, for instance, I'm going to totally make this up. Let's say there was a negative right here, negative 8.68. This whole thing is done. That means that triangle does not exist, and you would just tell me this triangle is the only one that exists, okay? This one right here. That's the only one that exists. But that's not the case for this problem, okay? This problem does not have a negative answer. It actually had a positive answer, so I don't know exactly how I'm going to erase. Let's see if I can totally do this. There we go. So this answer was positive, so that means we continue looking for this answer. So we still do B over sine of capital B equals, our asterisk problems were the A values, if you remembered. And so we put the 8 on the top and the sine of 30 on the bottom. We end up cross multiplying and solving for the B. So go ahead and set it up. So it should be 8 times the sine of 8.68 divided by sine of 30 degrees. And so once you put that into the calculator, set it up, you will end up with a length of B being 2.41. So in this scenario, for this delta math, you ended up with two solutions, two triangles. So you would hit the plus sign in your delta math to generate two boxes so that you could put the answers of the two things that they're asking for. Are they asking for the two B values? If they are, you would type in 8.68 from this page and 111.32 from this page. Or if they ask you for the little, the B's, the little B's, you would type 14.91 on one box and then 2.41 in the other box and so forth. But you'll see it once you start working out those problems. So that's how you work the ambiguous case problems for law of sines. They are a bit of work, but these are the only three classifications that you will see for law of sines. The SSA, which is your ambiguous case, and the angle, side, angle, which is the easier one. And those will always just be one triangle, okay? One triangle or no solution, my bad. So that's it. Thanks for watching.